As product reliability and quality concerns dominate the news, the need for product identification, detailing part numbers, manufacturing location, manufacturing time, and inspection verification is growing rapidly. While many products or subassemblies can be identified during the manufacturing or assembly process using automated marking systems, a lot of these systems do not supply the variable information required to detail exactly who manufactured the product, where, and at what time. Ink marking has been one of the marking methods used for product identification for many years, first with rubber stamps and wheels, and more recently with industrial inkjet printers. The advent of the industrial inkjet printer has allowed users to apply constantly variable information to products with a few keystrokes or automatically through computer interface. Development of new inks is increasing the number of industries where ink identification is finding acceptance. The one requirement to use industrial inkjet printing is reliable motion. Either the product must move past the printhead, or the printhead must move past the product. On conveyor or automated assembly lines where the product is always the same, this is a relatively simple issue. But what can be done to offer the benefits of inkjet printing to products which are not conveyed because of size, shape, print, location, or even volume? To address these issues, we developed a group of products to allow inkjet printing to be used in nearly any type of marking application where ink is an accepted medium. These systems were originally developed for the aerospace industry, where product batches tend to be small, product sizes range from rivets to wing panels, product number count is huge, and the need for product identification is critical. While each product was developed to address an individual marking requirement, the systems were designed to work together to provide the most versatile ink marking system available. One of our first developments consisted of a handheld device for an inkjet printer. The concept was to give the user the ability to position the printhead at the product, and with the pull of a trigger, the printhead would move across the part producing the mark. This system worked great for pieces hanging on a paint rack or set up on carts or pallets. The 20-foot umbilical provided a wide range of mobility, but we found operators were having difficulty holding both the part and handheld marker when marking odd shapes and smaller sizes. To increase the flexibility of the handheld, we immobilized it. A fixture was used to hold the handheld in a horizontal configuration, and a foot switch was added to allow the operator to hold the product with both hands while applying the mark. Marking productivity of smaller products increased. We then noticed that large batches or extremely small products seemed to take longer than acceptable. Re-enter the conveyor. Conveying a product offers the fastest way of applying a mark. The issue is how to set the printhead up quickly to use its productive advantage. Here we took inspiration from the offline tapping industry. The parallel arm fixture gave us the flexibility to quickly position the printhead anywhere over the conveyor surface and at any height. To make the fixture easy to use, we counterbalance the system weight with air cylinders and provide a quick clamping system to hold the fixture once it is positioned. A swivel joint at the head allows marking at angles from 0 to 90 degrees. Sensing of the product to be marked is provided by a fiber optic sensor mounted directly to the printhead. With this mount, the sensor is positioned when the printhead is positioned. In the aerospace industry, we found that both the handheld and the conveyor were sometimes required to provide the ultimate marking productivity. To accommodate the quick changeover from handheld to conveyor, we adapted the handheld to mount directly on the parallel arm. By removing the handle, the traversing part of the handheld can be positioned on the arm and locked into place. The photo eye is wired to the trigger cable, and the unit is ready for operation. Another advantage to putting the traversing unit at the end of the parallel arm is the conveyor bed becomes a table for marking longer products. The arm can also extend beyond the conveyor to mark product brought in on a cart or lift. The aerospace industry also manufactures round products such as bearings and rings. For these products, we adapted a rotating parts marking system which was developed for the circular connector industry. By rotating the product past the print head, the part mark can be applied around the outside or top circumference. The adjustable print head holder is used to allow precise print location on the product. Advanced marking productivity is lost if data entry slows the process or incorrectly identifies the product. Our APS 2000 software was developed to speed data input, provide storage for part numbers and formats, and allow the use of the printer's graphic capability. The software uses an input system that allows the operator to enter industry-specific information on the computer using a barcode scanner or touchscreen keyboard. The system can automatically locate scanned data using prefix identifiers. To simplify message format, a line number order system is used. This is password level protected to ensure proper formatting. The software includes a graphics builder that allows the user to develop logos or inspection stamps for use with the message. Data can be stored by part number or format type. A totally self-contained touchscreen computer was selected to eliminate the cables associated with separate keyboard, mouse, and monitor. The small footprint was also very appealing. The removable floppy drive prevents unwanted software from finding its way on the computer. To top it all off, the system is mobile. Unplug the electrical and air and roll the equipment to a new location, and it's ready for its